Hello everyone, welcome to this video. Here I'm going to be introducing you to the concepts that we'll be covering inside this course. So in this course, I'm going to be covering two main things. Firstly, the basics of using Langchain chains, and secondly, utilizing Streamlit to interact with our chains. So if we look at the conceptual view of the chains we'll be building in this course, we'll have a retrieval chain for our data analytics. So before I get started, let me just say we will be building a data analytics chatbot in this course. And in order to get or extract the data, we have a retrieval chain, which allows us to subset our data set based on a LLM generated query. So the LLM will be writing code for us to subset a data frame. And once we subset that data frame, we're going to be taking that data and we are going to be passing it down to our aggregation chain. So inside our aggregation chain, we will have three different components. First of these components is going to figure out what we wish to do with the data. So what kind of analytics do we want to do? Do we want to, say, get a sum of a column? Do we want to get a mean? Do we want to get the min or max? And then next we will decide which column we are looking to deal with. So we will decide which column names do we want to aggregate over, and lastly we'll put that all together inside our aggregate module. All right, so this is going to be the chain that we build, and although it seems a little bit simple, if you think about what we're doing here, we're just essentially getting the data and then we are doing some aggregation on it, like a sum or a mean, and then presenting that data back to the user. But this is something that essentially ends up taking 2 hours, so it is a substantial amount to learn, especially because LangChain and Streamlit might be something that's new for you. So it's explained in that way so that any beginner can pick up. And let me also give you a view of what this will look like. So here you have the e-commerce chatbot, and you have your ChatGPT like prompt that you can send. So an example prompt can be, please give me all the sales records for wireless mouse. It prints out the data frame, and then you have another prompt saying, please give me all the sales records for laptop stand. And then it subsets the data frame so that now you have all the records for laptop stand. And we also have an output for the aggregation. So here, if I say, please give me the total order value for the sales for wireless mouse, we have 503.62. And that is just an example of what you'll be able to build. And I hope you're excited. So let's get started. Thank you for joining me, and see you in the course. Hello everyone, welcome to this video. Here I'm going to be showing you how we can use Streamlit to create a simple front end for our e-commerce data analytics bot. So in order to get started, we're just going to go over to the free section and we'll hit login with GitHub. And this brings me directly to the dashboard. If you don't have a GitHub account, you should just go and create one, and then you'll be able to log in and see this dashboard as well. So we're going to go to create app, and then we're going to deploy a public app from a template. And the template I wish to use is for our LLM app. It's going to be the chatbot. And essentially this template allows us to create a simple wrapper-like chatbot on top of OpenAI by giving an API key. So let me just go down, and we want the GitHub code spaces to open immediately. So we'll just hit that and hit deploy. So while this is creating our application, let me just talk about what Streamlit is and why we use it. So as AI developers, or as a backend developer, or even as a full stack developer, creating front ends usually becomes a tedious task, and many times we don't have the skills to create a customized front end from fancy technologies like React that you'd have to spend some time to really learn and develop. So Streamlit essentially allows us to create the front end and to use some very beautiful UI components without really having to worry about creating them or without worrying about how to make them interactive. And all that headache is taken over by Streamlit. So here in this video, I'll be showing you some of those components, and you'll really come to appreciate how you're able to focus on the LLM side of things, on the AI development side of things, and sort of let Streamlit abstract out the rest. So this is going to take a little bit of time, so I'm just going to forward the video. Alrighty, so here is our application, and this window looks very much like VS Code because it is the GitHub code spaces, and it essentially uses VS Code to provide you an IDE inside your computer directly via a remote link instead of having you set it all up on your own VS Code. So that is another sort of benefit for people who are just getting started. And in order to play around with this application, I'm just going to get this to open in a new window. Okay, and here I'm just going to close this out, and we're going to go over to OpenAI. Now, if you guys have been using ChatGPT, you will not have an API key. So in order to get an API key, you'll have to go over to login, go over to their API platform, and there might be some intermediate steps. They will make you fund your account with $10. So that $10 is going to last you a long time. So don't worry. I would say it's a good investment to get started in AI, to have a API key and a funded open AI account. Okay, so inside here, you just click on your name and go over to your profile. Here you can go over to API keys, and I'm just going to create a new API key. I'm going to call this Streamlit and create this API key. All right, so close your eyes real quick, guys. I'm gonna copy my API key, no peeping, and just going to go over to the Streamlit application and paste this in. Okay, I'm going to press enter, close out of this, and here I'm just going to say, hey, what's going on? Just to test our connection. And sweet, so we have our connection, it is live. And here I'm just going to change the theme a little bit. I personally prefer the dark theme, so I'm just going to change this over to dark. Okay, sweet. All right, so we have our chatbot going. And you can really appreciate how easy that was to set up, because if I show you the code, you can see that obviously since we are deploying from a template, it was indeed 1 or 2 clicks for us. But there is a lot of abstraction in the front end UI side of things. So you can obviously see that there's no HTML or CSS or no JavaScript components. Essentially, the UI side of things is very much declarative in Streamlit. So we have our st.title, and then that defines the chatbot over here. We have our text that we've written out, and that defines the description over here. And we have our text input over here to paste in the API key that corresponds to this section. And all of this is defined in 3 lines, which is absolutely amazing if you're if you've ever tried to develop a front-end application. So let's go through this, and let's also make some changes and make it our own instead of it just being a template. So I'm just going to change this out to e-commerce analytics chatbot. Okay, so we're just going to change this to 4.0 mini, and get rid of all of this information. So I'll say this bot lets you analyze data and create visualizations using natural language. Okay, let's hit save and let's go over here and just do a quick rerun. And you can see that we have our updated title and description. So let me go down, let's keep continuing and explain you overall what's going on and how this is working. And don't worry if this seems complicated, I will explain everything as the next videos progress, because we'll be diving deep and making changes to this code. So I already mentioned what this does. This is where you paste in your API key, and it checks to see if there is anything pasted in the open API key section. And if there is nothing there, it is going to say, please add your open AI API key. But if you have pasted something in there, then it is going to try to create a client and create a connection with OpenAI. And it is going to do something over here, which is it's going to check if there's a messages variable inside the session state. And if there's no messages variable, then it is going to create a new messages variable for us. So what exactly is going on with this session state? Now, the way that Streamlit works is it provides you the UI, yes, but when the user interacts with the UI, it also has to take care of the JavaScript that goes on with responding to that interaction. So there is a static website, or there's a static component. The static component is just displaying this text to you. But there's also a dynamic component, which is when you paste in information or when you interact with an input field, the Streamlit application has to do something in order to carry out your wishes or to carry out your commands. And what it does is that every time you interact with the Streamlit application, it is going to rerun the entire application and re-render the entire code. Now, that might seem scary because, when I first heard that, I thought, oh no, it's going to run everything. It's going to, cause all sorts of latency, because if a certain piece of code took, 20 minutes to run, it's going to rerun that every time I interact with it. And that's not necessarily the case if you code it correctly. And the way to deal with that problem is to save the data you wish to be displayed to the user inside a session state variable. And that's exactly what's going on in this situation. So what's happening is, if I come back here, if we go over to the messages over here, what essentially this does is, if you are just starting out, so if there are no messages, it is going to create a new variable in the session state, and it is going to save this variable through the app reruns. So each time you interact with an application or do something, it is going to save these messages. So when the app reruns, these messages are going to persist, and it is going to go inside the messages and then print them out for us, so that the conversation history doesn't just disappear because you interacted with it. So let me go down and let me show you how the application gets updated when you submit a new prompt. So here we have chat input. And if I go over to the chat input, you're going to type something over here, just like we did. We said, hey, what's going on? And then when you press enter, what it's going to do, it is going to store and display the current prompt. So it is going to append it to messages, and messages is the variable which contains all of the messages and persists them through reruns. So it is going to append your current message, your newest message. It is going to say, okay, it came from the user, and the content of that message was prompt. Okay, so here the st.markdown, this is just how it displays messages out. So it is going to display that message. And then if we go over here, it's going to generate a response from OpenAI. So it is going to stream a response. And if you have created, or if you have asked more complex questions in ChatGPT, you know that the answers are streamed out to you. So it is not like you have to wait 5 seconds for the entire response to be generated. It starts streaming the tokens as they become available. And that's essentially what you do when you say stream is equal to true. So this section takes care of that. And then when you go down here, it is going to output that chat message to the application. And then it will append that chat message with the role assistant and the content response. And then the next time the app reruns, so if there was like a radio button and you pressed submit, next time the app reruns, it will save this as a user message and this as an assistant message so that it knows which image and which logo to send over here. And then it will just print those out and be ready to take your next message. So I know that's a little complicated, and what I'll do is in the next video, make this much more concrete by giving you guys an example. We'll add a sidebar, and then we'll see how making changes to the input inside that sidebar affects the way that the messages are being displayed. So with that, thank you so much for joining here. Be sure to like and subscribe and check out the links in the description to get more resources. If you are a business owner and want to implement AI or automation into your business, you can reach out to us and I'll be happy to chat with you. Thank you so much and see you in the next video. Okay, so now that we understand a little bit about how the code is structured, let's just add another component. And this component is going to allow us to select which data source we want to utilize for our application, for our LLM responses. And before I do that, actually, let me just change the theme here. So I'm just going to do greater than symbol theme, and here I'm going to say color theme, and I will make this dark. Okay, sweet. It's just so much better for my eyes, and it honestly, I don't know, maybe you guys disagree, but I think it looks much, much better. Okay, anyways, so here I'm going to just insert this, and this is going to be a sidebar, and it is going to be having a drop down to select data source. So we're going to be having a few tables inside the e-commerce data set or the database, and this will essentially let us select which table we wish to use. So we'll just say selected data source is equal to st.sidebar. So this should create a sidebar for us. And then have dot selections, or sorry, dot select box. And here I'm going to provide it the input. So we'll say select your data set. And here I'm going to just provide it the options that it can select from. So here we'll just keep it generic. We'll say table A, table B. All right, fantastic. So that should create our data source. And then we also just want to write out what the user selected. So here we're just going to write out the selection, something we're going to get rid of, but it's sort of like a print statement where you're just printing out what the user selected. So you said you selected, and here I'm going to say selected data source. So how exactly does this work? So when you assign this component to selected data source, to this variable here, what you assign is the value that is held by this component. So this creates the component. This creates a sidebar, first of all. And then inside the sidebar, it adds a select box. A select box is essentially a drop-down menu. And the drop-down menu has this as its instruction. And then it has this as its input options. So you create this, and then you assign the value which is picked by the user to this variable. And then you can directly access that value by just using it as a variable. It's like a string variable essentially that is accessible to you, and you just use it just like any other normal variable inside Python. All right, so let's just see what happens. I'm going to hit save, to go over here, and we're just going to rerun this application. Fantastic. So we have a sidebar now. And here, if I say table B, you can see we have selected table B. If I go over and say table A, it says selected table A. Now let's also just access this variable inside our LLM. So we're going to do something pretty simple. We're just going to come down to our prompt. And this is where we're appending the prompt to the messages. And we're going to say plus, I'm just going to say the user selected, and this is going to be our variable that we created, selected data source. User selected data source. Okay. Whoops. So let me just add the plus over here. Okay, that makes it correct. All right, let's just save that. And that's looking good. I'm just going to go over here. Just going to do a quick rerun. And I'm going to say, okay, which table have I selected? And you can say, great choice. How can I assist you with table A? Fantastic. So it's picking out which table we selected. Now let me do one more thing, which is very interesting. And let me select table B. Ah, there we go. So did you see what happened? Initially, we just had this component over here, which is which table have I selected? And when you made a selection, when you changed the input, the entire app reran. So the Streamlit application reran, and when it had stored the prompt, so when it stored the messages, it stored this component as well, because we added it to the prompt. And since we added it to the prompt and that's what it stored, when it reran, it picked up from that storage and printed out this component as well. So obviously we're going to get rid of this and deal with that in a different way, but it shows you how this rerun sort of thing works in Streamlit. All right, so that was a lot. And congratulations on creating your first chatbot in Streamlit. So thank you, and we'll continue working with this in the future videos. We'll see you there. Welcome back, everyone. In this video, I'm going to be showing you how you can safely store your API key inside your code base. So as of now, what we were doing is we would have had to paste our OpenAI API key into this input box for the e-commerce analytics chatbot to work correctly. But if we want to avoid doing this, and if we want to store the AI API key inside our Streamlit code base, what we have to do is we have to store it in something called a secrets.toml file. So what exactly am I talking about here? So if you see over here, we are using a text input to get the API key. What I'm going to do is I'm going to define a file. So first I'm actually going to define a folder. And this is going to be called .streamlit. And inside this folder, I'm going to create a file called secrets.toml. Now, why can't we just place the API key inside directly here and just replace this with a string field? The reason for that is that when we save this and when this updates or when we commit changes to our GitHub repository, the API key is going to be sent in there, and anyone who has access to our GitHub repository is going to be able to see our API key. Now, that is something that we would like to very much avoid. And if you create a secrets.toml file, and if you place your API key inside here, what gitignore does is that it actually ignores this secrets.toml file so that the API key or any other sensitive data is not stored on the GitHub repository, and your keys are at least a little bit safer this way. So let's go back to secrets.toml, which is the file we just created. And inside here, I'm going to define the variable. I'll say open AI API key is equal to, And here I'm just going to go over to OpenAI, to login, API platform. And here I'm just going to go over to your profile, go over to API keys. And here I'm just going to revoke this one, just create a new one by the same name. So here I'll say Streamlit. Okay, so we have our API key now. Let me paste this. Get rid of this one. Let me paste this inside here. Hit save. And now I'm going to go back to our Streamlit underscore app. And I'm going to get rid of all this that we have that is connected to the text input. So we'll get rid of this. And we'll also remove this if statement or this else statement. Okay. And I'm just going to highlight all of this and do Shift Tab so that we go back one level of indentation. I'm just going to get rid of this completely because we don't necessarily need an extra variable now. I'm just going to type st.secrets and I'll say open AI API key. All right, so this has to match the variable name that we gave over here. Just to make sure that is correct. Yep. Okay, so now I'm going to hit save. And if I reload the application, we should get rid of that text input. I just remembered we had this table that we were selecting, so I'm going to get rid of that from our chat messages. I'll just remove this. So this is from the previous lecture where we were talking about how the reruns work in Streamlit when a user makes a change. Okay, let me just reload one more time. So it doesn't affect this here, but it will affect the messages that we send. So here I'm going to say, hi there. We get a response, sweet. Just going to ask it something. What's the birthday of Benjamin Franklin? Okay, fantastic. So that proves that our API key is now working correctly. And the added benefit, as I explained, of storing it inside here as a variable is that this will no longer be something that is updated onto our GitHub repository when we commit changes. That is very important to do. Otherwise, your keys can get stolen and it's just very insecure because somebody can get access to that key and start racking up or using up your credits. So with that, thank you so much for joining here. Be sure to like and subscribe and check out the links in the description to get more resources. If you are a business owner and want to implement AI or automation into your business, you can reach out to us and I'll be happy to chat with you. Thank you so much and see you in the next video. Welcome back everyone. This is Dhruv Bass and in this video I'm going to be showing you the basics of LangChain. So let's get started by first installing the required libraries. You can very easily do this by coming over to a new terminal and just typing in the two commands over here, pip install LangChain and pip install LangChain OpenAI. Since I already have these, I won't be doing that. So let's just get started with importing the right packages. We'll do the usual Streamlit import. And from LangChain OpenAI, we're going to import chat OpenAI. This will allow us to connect to the LLM. And then we will also do LangChain underscore core dot messages. And here we will import the system message. So this is how you send system messages, which are like messages that instruct the system, the LLM, how to respond, the AI message, which is the response from the LLM, and then the human message. Okay, so that's all we need. I'm going to create our chain. So I'm going to say chain is equal to chat OpenAI. I'm going to define the model as GPT-40, and here I'm going to provide the API key as the API key we stored in the secrets.toml file. So if you haven't done that in the previous video, you can go over there and check out how we did that. So here we're just going to type in the name for our API key, and this references this secrets.toml file where we have a variable called OpenAI API key. All right, so that should handle connecting to the LLM. And now we're going to just set up some messages. So this is just a message history. We are beginning in the middle of a conversation. The system message that we have is going to be having the following content. It's going to say, you are an e-commerce database agent, and we're going to pass it in some data. Whoops. We're going to get the data to be generated by ChatGPT. So we'll say revenue data is equal to, I'll just give it a multi-line string. And let me go over to ChatGPT, and what I'll search is give me random revenue figures for an e-com store for 12 months so that I can copy and paste them. Because if you don't give this, it will try to give it as a table, which is hard to copy paste. Or it will, if you ask in a CSV, sometimes it will tell you to, it will give you the downloaded file, which is not that difficult to open and copy paste, but that's just an extra step we don't need. So here I'm just going to copy this. All right, so there's our data. Now this seems like a toy problem, which it is, but to get started and to get a handle on LangChain, this is going to serve our purpose wonderfully. So here I'm just going to append this data. And the system message sets the instructions. Now we're going to add a human message, which in this conversation history represents the first message sent by the human. So we're just going to say, please tell me the revenue figures for August. Okay, that should be easy enough. So messages contains all the messages, and in order to generate a response, we say response equal to chain.invoke. So chain refers to this model over here, and here we're just going to say chain.invoke, and we will say messages. So invoke is essentially going to send over this messages list that we have, and it is going to be passing on all of the information inside it to the LLM so that it can generate the appropriate response. And here I'm going to just do print, and we'll say full LLM response. We'll do response. And to get just the text output, we'll say LLM response content, and let's say response.content. All right, so let's take a look at what this outputs. In order to execute this inside Streamlit, you just have to do Python langchain funcs.py. And there we go. So the output over here is in two parts. We have our full response and then the content. So inside the full response, we have the first value as content, and here it says the Revenue figure is 17,890, which indeed is correct. And then you have some extra metadata like the token usage, completion tokens, prompt tokens, so on and so on. And then here, when we do dot content, this gives us the text content that was inside the response. All right, so that's a very simple invocation of the LangChain library, and hopefully that was easy enough to understand. In the following videos, we're going to be making this much more capable and giving it tools, giving it agentic capabilities, and so on. So thank you so much for joining me here, and see you in the next video. Hello everyone, welcome back. This is Dhruv Bas, and in this video I'm going to be showing you how to create your first chain in LangChain. So the purpose of this chain is going to be to allow a user to subset a data frame from a natural language prompt. So what's exactly going to happen here is we're going to have these different components for our chain. The first one of the components is going to be our prompt template. And this is essentially where we have our prompt, and then we have a section which says input, and it's essentially like a fill in the blank or a insert here. And once we get the input from the user, we insert that input into that prompt to complete it out. And then we have our LLM to generate our query. The query is going to be the piece of text which we use to subset our data frame. So the LLM is actually going to do a little bit of coding for us, and it's going to generate the query that we use to then filter out the exact records our user is asking for. And then we'll have a output parser. This is just an intermediate step to get the string output from the output that the LLM provides. And then we have a retrieve data, which is going to be the step in which we actually utilize the string output that we get from our LLM to subset our data frame. So we'll keep this in mind and we'll refer back to this as we're building this chain. But let's get started on the actual chain over here. And if you remember, this is what we built last time. What I'm going to do is I'm just going to comment this out. And we're going to start fresh. Okay. So here we're going to make sure that we have all of the important imports. So we're going to do from LangChain dot prompt import prompt template. So this is what allows us to create those incomplete prompts which get completed when we get an input from the user. So we'll import our str output parser. This allows us to parse the output we get from the LLM and get it in a nice string format. Then we have schema.runnable, and from here we're going to import runnable branch, runnable lambda, and runnable pass-through. So what exactly is this runnable? It's essentially what each component inside the chain is called. So if we go back to the whiteboard, this is one runnable, this is one runnable, this is one runnable, and this is one runnable. So runnables are components of the chains. That's basically what it is. And in order to create those runnables, you have to import these. These are the different components that we'll be utilizing in this chain and in the future chains that we're going to be building. So let's go down, and we're also going to import pandas as PD. So if you haven't installed pandas yet, the installation's super simple. It's just pip install pandas. Okay, so let's go down and let's start building our chain. So first things first, we want to generate some new data. So we're going to go to ChatGPT, and we're going to try to get a new data set. The prompt that I'm going to use to generate this data set will be generate 100 transactions spanning 12 months for an e-commerce store with details like product ID. We have product description. We want the price of the product, the quantity, the total order size, the customer ID, and also the customer name. So we'll say this is company. And we'll also say that there should be approximately 10 unique customers. Okay, so let's see what this is able to generate for us. All right, fantastic. So we have our transactions. Let's just make sure the columns are correct. Okay, it looks more or less correct to me. Okay, I'm just going to download this. Downloads as a CSV. Let's go back over here, and here I'm just going to upload it to downloads, commerce transactions. Just get rid of these previous ones that I was playing around with earlier. So let me just delete that permanently. Okay. So this is the CSV containing our transactions. Let me go back over here and let's read it into our data frame. We'll do df is equal to pd.read underscore CSV. And here I'm just going to get the name. Okay. And then let's just take a look at what the data looks like. So we're just going to do df.head. To run this in a new terminal. Looks like there's an error here. Okay, let's make sure we get rid of this comma. Okay. Sweet, so we are getting our data frame as we expected. So now we're just going to create our LLM component. So this is going to be the LLM that runs the query. So let's say chat OpenAI, and we'll say model is equal to GPT-4o, give an API key, and that is going to come from our secrets.toml file, and this will be OpenAI API key. All right, so that should be our LLM. Now I'm going to define the prompt that we're going to be using. So we'll say retrieval underscore prompt. So just to go back and reference, we created this, and here we're creating this prompt template. So retrieval prompt is equal to prompt template dot from underscore template, and here we're going to have a multi-line string, and here I'm going to say based on the following input, and I'm going to give it the input in quotations. So I'll say input underscore text. So this is what I meant by giving it a fill in the blank. So this input text in the curly braces is going to be replaced, but the data that's going to be in its place is going to be placed inside these single quotations. Okay, so here I'm going to do create the appropriate query to be used to filter and return results from a Python data frame. So here we're just going to say this is going to be for the function df.query. Now, in order for this to work correctly, we also need to provide it the column values or the names of the columns that our data frame has. So we're going to pass in the data frame has column values, and here I'll again do the fill in the blanks and say call underscore vals. And let me also give it a command to make sure the data is in the right format. So only return the query to be used inside the df.query function and nothing else. So otherwise it will give you nonsense like, here is the query, or it will say, oh, here's the query and this is how the query works and so on. So we don't want any of that. We just want the query itself. All right, so that creates the prompt template. And before we utilize the chain, we're actually going to fill out part of this prompt template. So we'll just save it again as a retrieval prompt. And we're going to fill out the column values portion of the prompt template. So I'm just going to say dot partial, which means it's going to fill out partial or part of the prompt. And here I'm going to say call underscore vals is equal to df dot columns. So df dot columns is a convenient way of getting all the column names, and this should fill it in inside this section so that the LLM has the appropriate information for creating the query. Okay, with that, let's create part of our chain now. So here I'm going to say chain, and we'll have chain is equal to retrieval underscore prompt. So that is the first component inside our chain. And then we have our LLM. So pipe this over to LLM, and the language or the framework I'm using here to create the chain is called LCell, and that is the LangChain's framework for creating chains. There are other methods of doing the same thing, but to be honest, this is the fastest way of doing this. So this pipe operator essentially will pass on whatever input it gets from the retrieval prompt onto the LLM. And then if we put another pipe operator over here and say str output parser, it is going to pass on the output from the LLM to this str output parser. So we're just going to save over here and see what we have produced so far. So now I'm going to do a run of our chain, and I'll say user underscore input is equal to input underscore text, and I'll say please give me all the sales records for, let's see, let's pick out a product. So here I'll say for wireless mouse. Okay, and then I'm going to have response is equal to chain dot invoke. So invoke is how you activate this chain, and we're going to invoke it with the following user input. All right, and then we're going to print out our response. Sweet. Now let's just give this a run, see what happens. Okay, so we're getting a little error saying the model GPT-4o doesn't exist. There was a little mistake in the typing over here. Let me just add a dash, and then let's rerun. Okay, sweet. So here we go. We have the output. This is what we were outputting earlier anyways. And then we have the output as these backticks, Python, and then product description is equal to wireless mouse. And then we have backticks again. So this is good. This is good. However, we don't want any of these backticks and this Python over here. And we actually also don't want this double quotation and this double quotation. So in order to get rid of this, we actually need another component that attaches to the str output parser. If I go back over here, so inside retrieve data, which is the last step, which we haven't coded yet, is where we're going to be having all of the data pre-processing. And once we do that, then it's just one line of doing the query and then returning the data. So let's go ahead and create that. I'm going to come over here, and this is how you will actually see how we create these runnable lambdas, which are essentially our own custom components. So far these, you haven't seen any runnable lambdas, but under the hood, this is exactly what these are. Now we're going to be creating a custom one. And the way that we do that is by creating a custom function first. So underneath prompts, I'm just going to create our custom functions. And inside here, we're going to define retrieve underscore data underscore function. And this is going to take a query string. Okay. And then we're going to do a printout before we get started. So we're just going to see what the query string looks like. So it's a query string before all of the modifications that we do. And then we'll say query underscore string. Now, what all do we need to remove from this? The first thing is we want to get rid of the backticks. So we'll say query string dot replace, and we want to get rid of these backticks and the Python that is showing up. So the reason why it shows up as Python is because it is the LLM's way of telling us that it created some code. So whatever it's returning is actually Python code. It does the same thing with HTML or JSON. So here we'll do replace, and then this time we will replace the backticks. So these are the backticks at the end over here, and we'll replace that with nothing. Now I'm also going to strip this of any spaces that might be in the beginning or in the end. So I believe there is a space between Python and product description. It's just not visible, and this will help us get rid of that. All right, so that gets rid of all the additional stuff around it. Let me also remove these quotations because that's not necessary. So here I will do query string is again equal to query string, and we will get everything from the second character to the second to last character. So this should get rid of the quotation, the leading quote over here and the ending quote over here. All right, so that gets our query in the right format. Now let me just print out our query string one more time. Call this after. All right, sweet. And I'm just going to also, while we're at it, just run this query. So we'll do df.query, say query underscore string, and then we'll return data. All right, fantastic. So that creates our function. Now this function is not ready to be used inside our chain just yet. We also need to create a runnable lambda. So here we'll say runnable lambdas, and I'm going to say retrieve underscore data is equal to runnable lambda, and we'll say retrieve underscore data underscore function. So this will just create a runnable lambda out of our retrieve data function. Super simple. And then we can place this at the end of our chain. All right, sweet. So let us give this a go. All right, beautiful. So what do we have here? What we have is we have the before string like this, and then the after string is exactly what we're looking for. And then the data frame over here is subsetted so that we only have a wireless mouse as the product. All right, sweet. So we are going to stop over here. And just a summary of what we accomplished is that we went and created a retrieval chain, which is going to be useful for all sorts of things that we do down the line. If we do any visualization or any aggregation on this data, we're going to be needing this retrieval chain. The retrieval chain has a prompt template. So over here, we have a prompt template, which is nothing but a sentence with a few fill in the blanks or some empty spaces where we can insert information that we need. So we insert the columns information, and then we also insert the user input. Okay. And then we have an LLM. That's super easy. It's just a connection to our chat GPT. And we have an output parser, which is a intermediate step to get the output from an LLM into a string. And then we did some data retrieval and also did some processing on our query to get it in the right format for data retrieval. So with that, thank you so much for joining here. Be sure to like and subscribe and check out the links in the description to get more resources. If you are a business owner and want to implement AI or automation into your business, you can reach out to us and I'll be happy to chat with you. Thank you so much and see you in the next video. Hello everyone, welcome back. This is Dhruv Bass, and in this video we're going to be reorganizing our Streamlit application. So if you remember from the previous videos, we had created a simple Streamlit app. So if I just go here, we had a e-commerce analytics chatbot, and we are going to be connecting this to our retrieval chain in just a moment. But before that, what we're going to do is we're going to make editing this much easier for us. So for now, what we have is we just have a lump of code over here, no functions, no organization, nothing. That is how the template was provided to us. We're just going to divide this up into different sections and put it into different functions so that we can edit each individual portion without having to worry about what downstream effects it might have. So for example, I want to be able to edit this portion if I wish without worrying about what it's going to do to this portion here. So let's get started on that. The way that we do that is firstly by creating two new files. So the first one of these is going to be called backend.py, and then the next one I'm going to call UI underscore components .py. All right, so here what I'm going to do is I'm going to first transfer over all of the UI components. So we have these components that we use when setting up. So here I'm going to just, actually I'm just going to grab all of this, just paste it here. I'm going to delete this. And here I'll define a function. So this function I will call setup UI. Let me indent all of this inside. Okay. And then I will call this function from inside the Streamlit app. So this will be the very first thing. Let's say setup the UI components. Okay. And we will call this setup UI. Now, in order for this to work, we just need to import this function from our UI components. So import setup UI. Now, before we move on, let's just make sure this works correctly. So I'm just going to reload this. And if all of our components show up like they do here, it means that it worked. Okay, sweet. So now I'm going to replace all of the backend setup components. So this is, I mean, backend front end on a Streamlit app is kind of discretionary. The front end components or the UI components, I'm just calling it that because they happen to be static and they're not really, dependent on any kind of deeper logic. These ones are slightly more dependent on logic and what's happening in the backend of the application. So I'm just calling them backend components. Okay, so I'm just going to cut this over and paste it into backend. And let me copy paste the import statements as well. Okay, we'll do the same thing. We'll say def setup backend, and then let's put all of this inside it. All right, let's go back to Streamlit app, and here we'll say setup the backend, which means client and messages list, and also display the previous messages on app reruns. Okay, and here I'll say setup backend. Let me import that from backend. Alrighty. And there is one more thing we need to do, and that is that we need to return this client that we have. So that is part of setting up our backend, and we're just going to return that client so that it is accessible inside the application downstream, because we have this client over here. So I'm going to say client is equal to setup backend. All right, so let's make sure that is working correctly. So I'm going to say hi there, what's happening? Sweet. So the backend has been set up correctly. Let's just make sure that the reruns are also displaying correctly. So we'll say, what's the weather like in the Sahara? All right, sweet. So we have the Sahara like this. So we just need to get rid of this little portion over here, which is, let me make sure it's gone. Okay. Okay, so now it no longer should bother us. If we just reload, let's say, hi there, Sahara weather describe. All right, so now that section is gone. Okay, sweet. So we have the backend side of things working correctly as well. Now comes the important part, which is the chat messages. All right, so let's slice this section up. I'm going to grab the first one of these. I'm going to paste it inside backend.py, and I'm going to define the function display current prompt, and then this will take in a prompt. We'll paste that here. All right. So what exactly does this do? Exactly as the name suggests. So we'll be getting a prompt from the input. So here we have st.chat input, what is up? So this is where your user prompts go. And once we get a prompt from there, we are going to be passing it to this function, and then this function will append it to the messages, and then it will also display that prompt out to the user. Okay, so let's bring this back. I'm going to go over to the app, and here I'm just going to replace the previous code with this. We'll say store and display the current prompt. Let's also make sure we import this. All right, now let's do the next piece, which is this entire LLM call. So this call over here, I'm just going to grab this, go to backend.py, and here I will define a function which is going to be called LLM call, and this is going to take in a client, and these are the actions it will execute. and then it will return the stream. So the stream is essentially an object which is going to be allowing us to stream data from the OpenAI API instead of just waiting for the end of the output and then displaying it. This is much, much better because the user starts seeing the response immediately instead of having to wait a second or two. Okay, so now let's call this LLM call function. Here I'm going to just describe this real quick. Let's say generate a response using the OpenAI API. And this is done by saying stream is equal to LLM call. And we're going to be passing in the client. So let's scroll back up and let's add this in as always. All right. So now we've got the last section, which is this part over here. And here we're again going to just grab this whole thing, go over to backend.py and create our last function. So this is going to be called stream LLM output. And this inputs a stream. Let's paste this in here. Okay, so this is going to write our stream, and then it's going to append the assistant output to the messages so that it can be printed out every time we have a rerun in the application. Alrighty, so we are very close to being done. Here I'm just going to give it a comment, stream the response to the chat and store the assistant message inside messages list. Right, we'll say stream LLM output, and this takes in the stream from the previous one here. So let me just add that in to our import as well. And all right, drum roll, let's try this out. Let's make sure we reload this. And again, I'm just going to have a greeting. Let's say hi there. When was Abe Lincoln born? Fantastic. So it is able to have multiple conversations, and we're displaying all the text correctly as well. And now if you take a look at what we have versus what we had in the beginning of the video, this is way, way easier to understand what's going on. And because you can understand things better, you can many times modify, update, and maintain them better as well. So thank you so much for joining me in this video, and I'll see you in the next one. Hello everyone, welcome back. In this video, we're going to start integrating our LangChain chain into our Streamlit application. So this is going to be part one of that, and this is slightly complicated. So I've made sure to split it up into different pieces so that it's easier to follow along. Now, the first step in doing this is to go over to our LangChain functions. And this is the chain that we had defined earlier. So we're just going to encapsulate this chain inside a function. And I'm going to call this def run underscore chain. And I'll say user underscore input. So this chain is going to take a user input, and the user input is going to be of the format that we have over here. So I'm just going to comment this out so that we don't end up using that. We use the input into this chain instead. So now that we have encapsulated our function inside LangChain, we are going to go over to our backend. And here we are going to define the chain call function. So here I'm just going to say, this will be yet another wrapper. So this will be chain call, and we'll say user underscore input. So user input is going to be a way of refactoring the input that is going to come from our chatbot user. The chatbot user is not going to give us input in this format, the dictionary format over here. It's just going to, or he or she is just going to give us input in this format. So we have to refactor it like this. Just copy this. And here I'm going to replace the input over here with this. Okay, so we just refactor this into a dictionary. And now we're going to do run underscore chain, and we'll say user input. So let me import this over from the LangChain functions. So here I'll say from LangChain functions, import, and our function here. All right, so that brings our function from LangChain, or our chain from LangChain functions, into our backend.py. And then now let's just test to make sure that this is working correctly. And here I'm going to first import. So I'll add this to the imports. The import is going to be for chain call. And I'm going to come down here and say run chain. And then we'll pass in chain call and do prompt. So what we want to pass into this is the string prompt that the user is going to be submitting from our chatbot. Now don't confuse this prompt with the retrieval prompt that we have over here. So we have a retrieval prompt over here. This is not the same thing. The prompt that we have inside the Streamlit app is the prompt or the user message that the chatbot receives, and then that user message is pasted into the retrieval prompt that we have inside our LangChain chain. All right, so here we're just going to test and see if this is working correctly. So I'm going to hit save, and then I'm just going to reload this one time. And I'm going to ask it a question. I'll just say, hi there, what's up? And let's see what happens. This should not produce any useful output for us, but it should show us that indeed our chain is being executed. So if we look at what the output ended up being, we can see the query string was hi there, what's up? And then that produced an empty data frame, because obviously that is not actual Python code we can use inside a query. So in order to get this to work, we're just going to copy paste what we have been using so far, which is this prompt over here. So this prompt I will now paste into our chatbot. So just imagine that the user asked for something like this inside our chatbot. And although the chatbot doesn't have that integration yet, if we come down here, and if I just open this up, you can see that in the previous case, we had this empty data frame, but in this case, we are getting our correct query, and then we're also getting the data frame that we wanted. So what does this mean? What this means is that our Streamlit app, the chain call that we're making, is working correctly, and we have integrated the Streamlit app. At least we have a working function, and that working function is connected to our backend and connected to our retrieval chain. So as I promised, this is a short one. In the next video, we'll be seeing how we can get the output that we're getting inside the chatbot. So with that, thank you so much for joining here. Be sure to like and subscribe and check out the links in the description to get more resources. If you are a business owner and want to implement AI or automation into your business, you can reach out to us and I'll be happy to chat with you. Thank you so much, and see you in the next video. Hello everyone, welcome back. Dhruv Bas here, and in this part I'm going to be showing you how we can get the output from our LangChain chain out to the user inside our chatbot. So we saw that in the previous video, we were able to get our chain response using this chain call. So this was able to connect us to the LangChain function that we had created over here. So we had created this chain and then we defined it, or we placed all the code inside a function, which we called inside backend.py, and then passed that along to our Streamlit app. Now, in order to get a chat response from this, we're going to start with LangChain funcs. So I'm going to go down here, and so far we're only printing a response. So we actually want to return a response. So we'll just do return response. Okay, so that takes care of that. Let's go over to backend.py. Now in backend.py, we need to define a function which is going to allow us to output our chain response to the chatbot. So here I'm just going to say define chain call output, and this is going to take in the chain response, and we'll say with st.chat underscore message, say assistant, we are going to define response as st.write our chain response. Okay, sweet. So that should write out our chain response. And the last step that we need to do in order to make sure this works correctly is to make sure we store our chain response inside session state. So we'll say session state dot messages dot append, and here we are going to append the following dictionary. So we'll have role. This came from the assistant. And then the next key is going to be the content of the message, and the content of the message is chain response. Okay, sweet. So there is the function which will allow us to output our chain. Let us go over to the Streamlit app, and I already commented out the generate response and the stream response functions. So right now we only have the run chain. Below this, we're just going to add our output chain response, and I'm going to call chain call output with the chain underscore response. Let's go to the top and import this in. So from backend, we'll just import chain call output, and that should be good. All right, let us give this a go. I'm going to go over to Streamlit app, and I'm just going to copy, before I do that, the message we've been using to test our chain with. Let's paste this here. Fantastic. So there we go. We get a data frame as the output for us. So this is, and in Streamlit, this actually looks really nice because that's what the app is for. They have specialized in creating beautiful UIs, and you can interact with this, you can copy these values, you can export this, and so on. But yeah, congrats on building all of this and following along. I'm sure it was difficult along the way. And there is one last thing that we still need to fix, which you might not see yet, but let me just send the same message again and let's see what happens. So actually, I'm just going to change this out for laptop stand, and let's see what happens. Okay, so we get the records for laptop stand. It looks nice. However, there is an issue with the way that this is being printed out now. So it is only printing the latest data frame as an actual data frame. This data frame that it had previously was replaced with just text. So how do we deal with this? We deal with this by coming over to our code base, going over to backend.py, and I'm just going to modify the way that we display all our messages. So currently we are displaying messages like this. I'm going to comment this out, and we're going to define a new way of displaying our messages. All right, so what I'm going to do is I'm going to say, again, for message in st session underscore state dot messages. So that part remains the same. And again, we have the with st dot chat underscore message, and we'll put message role. All right, so this part is the same. However, now we're going to start checking to see if the message content is a data frame. And if it is a data frame, we'll output it as a data frame. Otherwise, we'll just write it as a normal message. So here comes if is instance, and here we're getting the message content. So if the message content is an instance of pd.dataframe, and I believe I need to import pandas. So I'm just going to go up here and do import pandas as pd. Okay, let's scroll back down. And we finish out this if statement. So if it is indeed a data frame, then use the st.dataframe function to print out the message content. And if it isn't a data frame, then continue using st.write message content. All right, sweet. So that should take care of the issue we're having. Let me go over here and let me reload. While that's reloading, I'm just going to copy the prompt and paste it here. Okay, so that's working. Let's make sure the second one is also going to work. Okay, fantastic. So now you can see that we are indeed printing out two data frames instead of having text output over here. And with that, thank you so much for joining me. That's all I wanted to cover. We completed the integration of our retrieval chain into our chatbot. I will see you in the next video. Hello everyone, welcome back. This is Dhruv Bas, and in this video, I'm going to be showing you how to extend our bot so that it is able to do aggregation on top of our data frame. So I had promised you guys that we'll be building a data analytics bot, and so far we've only done the retrieval part of the step. So this is the chain we've been following to do retrieval, where we have a prompt template, then we use the LLM to generate the Python code, which is going to be the query we used to subset the data frame and then retrieve the data. Now, how do we extend this so that we add a aggregation step? The way we do that is by adding the following chain. So here we have an aggregation chain pass-through. Don't worry about the pass-through, I'll explain that in a second. And this portion over here is what's going to be carrying out the aggregation. So the output of the retrieval chain pass-through is going to be our data frame. And that data frame, that subsetted data frame, is going to come into this aggregation chain. And inside here, the first part of this chain is going to figure out which type of aggregation the customer wants us to do. So if they want us to do, say, a mean or a sum or a min or a max, that is going to be decided here based on the LLM and the prompt that we have. And then the next step of that will be to figure out over which column we want to do that aggregation. So we have the same thing. We have a prompt to figure out which column to aggregate. Then we have our LLM, which executes the prompt, and then we have the output parser to get that output as a string. Now, once we have these two pieces of information, and once we have the data frame, the subsetted data frame coming in from the retrieval chain, then we can have an aggregate component, which is going to allow us to put all of that information together and then execute the aggregation. So we have column name, we have the data frame we want to aggregate over, and then we have what type of aggregation we want. And that is all the information we need to execute this code. So let me explain to you while we're at it what the pass-throughs are. So far, we have not needed a pass-through, and so far our chain has been pretty simple. Now, what do I mean by simple? What I mean is that the output of this component or this runnable inside our chain is all that the next component has needed in order to produce its output. So if we look at the LLM, all it needs is the prompt template and the blanks that we fill into it. Then the output parser, all it needs is the LLM. It doesn't need the prompt template anymore. The same thing with retrieve data. All it needs is the query. It doesn't need any of this information. When we go over to the aggregation chain, though, what happens is we need information from the previous components in order to be able to execute this final step. So what do I mean by that? If we have a aggregation that we're doing, we need the output from this step, which gives us the column. We need the type of aggregation, which comes from this chain over here, and then we need the data frame. However, if I just put this all together in a single chain, the component over here will forget about everything that happened beforehand. And all I will have is the column name. So what the pass-throughs are going to allow us to do, it is a type of runnable. What the runnable pass-through allows us to do is it allows us to preserve the information that came into the chain. So it will save the information that came into this component from the previous chain. And it will also append the information that you generate from the last component over here. So you are able to preserve the information and add on to it. So when you have this pass through, you're going to be passing on the input information that you had and the output. And then inside here, you're going to be appending to the data frame the type of aggregation that you want to do. And then inside this chain, you're going to be appending to the data frame and the type of aggregation you want, and you're going to be appending the column name over which you want to do the aggregation. So all of that will be presented in a dictionary to this final component, and then the component can execute all the aggregations necessary. So with that explanation, let's go over and actually build this out. So this is what we had previously. The first step for us will be to add the prompts. So here I'm going to add our aggregation prompt. So we'll have aggregation underscore prompt is equal to prompt template dot from underscore template. I'm going to put it inside a multi-line string. So let's spread this out here. And I will say, based on the following input. Again, we will give in our fill in the blanks. This will be input underscore text. Decide which type of aggregation the user is looking for. And then we'll say choose from mean, sum, count, max, or min only. And we'll just, for good measure, just add another little restriction and say only answer in one of these 5 values. All right, let's just format this correctly. Okay, so that's the first one of our prompts. Let me create another one. I'm just going to copy this over. And this prompt is going to be for figuring out the column. So we'll say underscore call prompt. And here we can leave this portion as it is. We do need to add the data frame columns. So here we're going to say, and the following data frame column names, we'll give this call underscore vals. Okay, put this on the next line. And instead of saying decide which aggregation, we'll say decide which column values is the user looking to aggregate. All right, let's also give our restriction. So I don't need this anymore, but to give the restriction, I will say only answer in one of the data frame column names provided. No additional info before or after. All right, so that should take care of our prompts. So that takes care of this prompt template and this prompt template over here. Let me also fill out the column prompt partially so that we have the data frame column values available to it. So we'll say it's equal to dot partial, and we'll say call underscore vals is equal to df.columns. All right. The next step after creating our prompts is to go and create our chains. So where we have defined a chain over here, first I'm just going to call this retrieval chain. And then I'm going to go down over here and say aggregation type chain. And this will be aggregation underscore type underscore chain is equal to, we'll say aggregation prompt, that is to be piped into our LLM, and then that is supposed to be piped into our str output parser. All right, just copy paste that. So we're gonna go down, aggregation column chain, and we'll paste this here. Aggregation call chain, aggregation call prompt, and that should take care of the two chains. Now I'll introduce the runnable pass-throughs. It's actually very easy to convert these into runnable pass-throughs. All we have to do is just go over here and define a runnable pass-through. So I'm just going to copy paste this. Runnable pass-through dot assign, and this is where you assign the dictionary value. So you assign your key and you assign your data, and in the data you assign your chain. So what's going on over here is, if I come back to our drawing that we have our retrieval chain pass-through, and essentially this is our retrieval chain that we have created. So that we just plug and paste as the value, and then this is going to be the key, and the key we're just calling as retrieve data. So when there is an output from this retrieval chain pass-through, it is just going to be a dictionary with the key as retrieve data and the value as retrieval chain. So we are just going to copy this and paste it into the other chains as well. And here I'm just going to call this agg underscore type, and this will be aggregation type chain. And here I'm just going to call this aggregation column pass through, and the retrieve data is going to be this chain over here, and the retrieved value is going to be call underscore name. All right, so now after we run through these, what we're going to have is we're going to have a dictionary with three key value pairs, and the first key value pair will be retrieve data colon retrieval chain. The second key value pair will be AGG type and aggregation type chain, and then the last one will be aggregation name and the value that comes out of this aggregation column chain. All right, so that creates our individual chain pass-throughs. And this video is getting a little long, so I'm just going to go over to the next one to finish this out. But to conclude, what we essentially have built is we have built out these individual components. So we have a retrieval chain pass-through, we have an aggregation chain type pass-through, and then we have the aggregation chain column pass-through. Now what we need to do is we need to create the aggregate function, and we need to link all of these together so that the data flows from the first retrieval chain all the way down to the aggregate function. So with that, thank you so much for joining here. Be sure to like and subscribe and check out the links in the description to get more resources. If you are a business owner and want to implement AI or automation into your business, you can reach out to us and I'll be happy to chat with you. Thank you so much and see you in the next video. Hello everyone, welcome back. This is Dhruv Bass, and in this video we're going to be finishing out our aggregation chain. So in the previous video, we had created these individual pass-through components, and let's see how we can finish out this entire chain so that we're able to do aggregations on our data frames. So this is where we left off last time. The first thing we're going to do is we're going to combine together the different aggregation chains that we have into a single aggregation chain. And we'll do that by defining aggregation underscore chain is equal to, and this is where you can just pipe together the different pass-throughs. So we have our type pass-through, and then we will pipe the column pass-through to it. Okay, so that's all we need to do for now. We still have an aggregate component, which we haven't built yet, but we will do that once we see some output from the aggregation chain. Okay, so here we're missing a chain, so we're just going to define the chain as well. We'll say chain is equal to, and this is where we're going to be passing in our retrieval chain pass-through, and then into the aggregation chain. So why does the retrieval chain have to be a pass-through? The reason is because we want to pass our data frame that we retrieve from this chain onto the aggregation chain, but the aggregation chain does not have to be a pass-through because all we're interested in is just the actual aggregation value. We don't need any of the information that came previous to that. All right. Everything else should work as expected. And let's give this a go. Okay, looks like we're getting some kind of an error. Let's go back and fix that real quick. So we're getting the issue in chain. Okay, let me just get rid of this. Let's reload. Alrighty, so this is not going to print out anything, I believe, but it will at least let us see what's going on. So here, let me find the usual prompt. Let's paste this. There we go. Sweet. So what we have as being outputted is we have the dictionary that we've been constructing. So we have the input text that is the first input into retrieval chain. We have the retrieve data, which is the output from the retrieval chain. And then we have aggregation type, which is the output from the aggregation type pass through. And then we have the column name, which is the output from the aggregation column pass through. And these seem to be correct based on what we've given. We have been a little bit vague on what we want to do with these sales records. So we're going to fix that in the next prompt that we send in. But it looks like everything is indeed working correctly as far as I can see. So let's go back and let's finish out the aggregate function. So if we remember, we have created this pass through, this pass through, this pass through. We are left with the aggregate function, which is going to combine this, and this information to aggregate our data. All right, let's go back. And the aggregate function is nothing too special. It's just like the retrieve data function. We're going to first define the aggregate function. This will take in an input. And we'll just print out the input, even though it is pretty clear to us from the chat over here what we're getting, but we'll just print it out for good measure. Or, sorry, it's input, not output. We'll do retrieved underscore data frame is equal to input, and we will access the retrieved underscore data, and then we will capture the aggregation type. That is going to be input agg underscore type. And then we have our call name. That will be input call underscore name. And then now let's subset and get the actual column data. So we have call data is equal to retrieved data frame. So from the data frame that was subsetted, now we want the column that is to be selected for aggregation. So once we have our column data, we can define the different operations that we want to execute. So for time's sake, I'm just going to give it two possibilities. I'm going to say sum, and here I'll say return call underscore data dot sum. So this will sum over all the values inside the column, and then we'll check elif aggregation type is equal to mean. And if that is the case, then we're going to do return call underscore data dot mean. And you guys can finish the rest of it out if you wish. So this is enough for us to test this function. And in order to convert this into a runnable lambda or a component that can be run inside an LLM chain, we're going to go over here and we're going to create a runnable lambda out of this. So we'll say aggregate is equal to runnable lambda, and we'll pluck the aggregate function into this. All right, so now we have our runnable lambda component. Let us add that to the end of the aggregation chain. So right here, we're going to say pipe aggregate. All right, so that should take care of doing our aggregation. Let me just change our input text so that it makes a little bit more sense and the LLM is able to get us a good response. So we'll say, please give me the total order value of the sales for wireless mouse. All right, so now we are going to copy this, go over here, hit reload, paste this in here. Let's go. All right, so here we have the number, and before we get too excited, let's just make sure this is correct. And if I go down here, you can see that we have date, order, product ID, description, price, quantity, and then total order size. So if we sum this together, we have about, I think, what is this? $503 essentially. And that is exactly what we get as output over here. So perfect. It was able to execute all the different steps that we have laid out over here, and it was able to aggregate over the data frame and give us an answer. So you guys can play out around with this more if you want. You can, make this output, look better, look nicer, and even test some of the other columns out. But this is essentially what I wanted to show you. And thank you so much for following along, and congratulations on building this. Thank you, and see you in the next video. All right, everyone, welcome back to the last video in this course. Congratulations on finishing everything, and let's just go through what we built. We built, firstly, our retrieval chain. So this chain allowed us to get our LLM to generate code for us so that we can subset our data frame. And then we converted into a pass-through, which allowed us to send in information like the prompt as well as the data frame that was retrieved over to our aggregation chain pass-through. And inside here, we grabbed the aggregation type. So whether it's a sum or a mean or a min or a max, and then we grabbed the column name. So which of the columns we want to aggregate over. And then we finally put it all together inside this final aggregate function so that we can run the aggregation on the data frame retrieved over the column retrieved and the type of aggregation that we wish to run. So these were the results that we got from our work. Firstly, we were looking at the retrieval side of things. So this is how we were able to retrieve data using a natural language prompt. And then we were also able to aggregate our data by giving a natural language prompt and having the LLM return the total sale value for a specific product that we wanted to work with. So, again, congratulations for building all of this. And, hopefully you guys got a good understanding of LLMs and LangChain and how to utilize that inside Streamlit to have a very beautiful UI for interacting with your LLM applications. All right, thank you so much for joining me in this video and in this course, and I hope to see you again. Thanks. Bye-bye.